LangGraph's interrupt mechanism enables dynamic suspension of graph execution to solicit external input, with the interrupt function serving as the control flow primitive that pauses execution and surfaces a JSON-serializable payload to the caller via the interrupt field. This pattern facilitates human-in-the-loop validation workflows by leveraging the checkpointer's persistence layer to maintain state across suspension and resumption cycles. The upcoming code demonstrates how to implement input validation using iterative interrupt calls within a loop, where each resumption attempt reevaluates the provided data against validation criteria until acceptable input is received. The implementation will show how the interrupt payload dynamically updates to reflect validation feedback, while the persistent, threaded, ensures state continuity across multiple resumption attempts.
From LangGraph, types import interrupt. Def get age node state. Prompt equals, what is your age? While true. Answer equals interrupt prompt hash, payload surfaces in result interrupt. Hash validate the input. If is instancing swar, int and answer 0. Hash valid input continue. Break. Else. Hash invalid input. Ask again with a more specific prompt. Prompt equals f answer is not a valid age. Please enter a positive number. Return age answer.
This code demonstrates a form validation workflow using LangGraph's interrupt mechanism. The pattern creates a persistent validation loop that pauses execution and waits for external input until valid data is provided. The getAgeNode function uses interrupt within a while true loop to repeatedly prompt for age input, validating each response before proceeding. When invalid input is detected, it updates the prompt with specific error feedback and triggers another interrupt, creating an iterative validation cycle. The approach leverages LangGraph's checkpointing system to maintain state between interruptions. Each call to interrupt pauses execution and surfaces the prompt in the interrupt field, allowing external systems to provide input via command resume equals. The validation logic ensures only positive integers are accepted, demonstrating how to enforce data constraints in human-in-the-loop workflows. This pattern is particularly useful for form-like interactions, where input validation is required before proceeding, though it requires careful handling of the persistent thread state via threaded to maintain continuity across multiple validation attempts. The design shows a trade-off between flexibility and complexity. While the interrupt-based validation allows for dynamic, user-driven input correction, it requires the entire node to re-execute on each resume, meaning any pre-validation logic must be idempotent. The pattern also depends on JSON-serializable values for interrupt payloads, limiting the complexity of data that can be passed through the validation loop. This approach is well-suited for scenarios requiring strict input validation with immediate feedback, but may be overkill for simpler validation cases where static prompts would suffice. Let's break it down.
From LangGraph, types import interrupt.
Imports the interrupt function from LangGraph's types module, which enables pausing graph execution at specific points to wait for external input before continuing.
Def getAgeNode state.
Defines a function named getAgeNode that accepts a single parameter, state, with type annotation, state. The function signature indicates it will process or return something related to age based on the provided state object, though the implementation details aren't visible in this segment.
Prompt equals, what is your age?
Assigns a string value, what is your age, to a variable named prompt. This creates a simple text prompt that could be used later in the code, though the specific usage isn't visible in this segment. The variable prompt now holds this question as its value.
While true.
creates an infinite loop that will execute the indented code block repeatedly until explicitly broken out of. The loop has no termination condition, so it will continue indefinitely unless interrupted by a break statement, return statement, or an exception.
Answer equals interrupt prompt hash. Payload surfaces in result interrupt.
Calls the interrupt function with prompt as the argument, which pauses execution and surfaces the payload in the result under the key interrupt. The function returns the value assigned to answer, which will contain the interrupt payload.
Hash validate the input. If is instantiansvar, int and answer 0.
Validates that the variable answer is both an integer and greater than 0. This conditional check ensures the value meets specific criteria before proceeding with further logic.
Hash invalid input. Ask again with a more specific prompt. Prompt equals f answer is not a valid age. Please enter a positive number.
Creates an error message string that formats the invalid user input, answer, into a prompt, indicating the input wasn't a valid age and instructing the user to enter a positive number instead. The message will be displayed to request corrected input.
Return age, answer.
Returns a dictionary with a single key, age, containing the value stored in the variable answer. This is a standard Python dictionary return, where the dictionary is constructed inline with the key value pair. The observable effect is that the function or method containing this line will return this dictionary to its caller. The interrupt mechanism in LangGraph creates a dynamic validation loop that persists across execution pauses, with the interrupt function acting as the control flow primitive that surfaces prompts to external systems. The infinite, while true, loop ensures continuous validation attempts, while the checkpointing system maintains state continuity through the threaded. Each interrupt call pauses execution and exposes the prompt via the interrupt field, allowing external input to resume processing. The validation logic enforces strict data constraints. Only positive integers are accepted, while the dynamic prompt updates provide immediate feedback for invalid inputs. This pattern balances flexibility with complexity. It enables user-driven input correction, but requires idempotent pre-validation logic and JSON-serializable payloads. The trade-off becomes clear when considering simpler validation cases, where static prompts might suffice, versus scenarios demanding strict input validation with iterative feedback. The persistent validation loop, combined with LangGraph's checkpointing, creates a robust human-in-the-loop workflow that maintains state across multiple resumption attempts.
The interrupt gobbles the prompt, spits out the age, and waits, forever hungry for numbers it refuses to swallow.